Ada yang ada masalah kesihatan, tak balik ke kampus. Dengar kan suara saya?
Dengar doktor.
Okey.
Dengar doktor.
Semua ada dekat college ke?
Saya kat college.
Okey. Okey, so macam mana kuis hari tu? Susah tak?
Susah doktor.
Susah kan? Tapi you did great lah, okey je. You jawab tu okey. Ada yang, maybe ada lah satu dua yang dapat kosong. So as long as you jawab, basically kalau you salah pun you akan dapat markah juga lah sebab your knowledge kan. Kita tahulah you tahu the step. Cuma maybe you salah tentukan dia punya height. Okay, wrong in the conversions of unit. So basically jangan bagi kosong lah. Try to answer at least. Okay, so for today you click on attendance week 11. Walaupun now we are in week 10, so we consider as week 11. Nanti during the study week tak ada cuti. So maybe we will do the revision class to replace class for week 10. Okay, so just follow the week accordingly. Nanti kita akan replace on the study week punya minggu. Okay, so marking tu tak habis lagi sebab kita buat syndicated marking. Saya dah marking habis dah. Tapi ada lecture lain belum marking lagi. So I cannot discuss on that quiz by this week, maybe next week. Okay, so we continue our class topic still in hydrodynamics. So before that, any question nak tanya? Ada So kalau along the way ada nak tanya, boleh raise your hand ataupun boleh on mic tanya. Okay, so let's see on the topic hydrodynamic fluid flow. So this one is for week 10 and week 11. The same reference that you might refer. Okay, so for today it is under 3.1.7, which is flow measurement. Okay, so before that, anyone want to share what is the continuity equation? Boleh, awak dah ingat ke belum? What is continuity equation? Maybe Razi Azman.
Ya madam.
What is continuity equation that you understand ataupun apa formula dia? What we can determine using continuity equation. Apa yang kita cari bila nak guna continuity equation?
Nak cari flow.
Okay, good. Flow ataupun discharge. So, apa formula dia, Razi? Flow, Q. Flow melibatkan ataupun orang lain nak tolong Razi ni? Harith? Muhammad Harith.
Betul.
Apa formula continuity equation? Lama sangat cuti ni. Ingat tak? 2 minggu study tak kat rumah? Harith,
Q in equals to Q out ya.
semula tak dengar. Putus-putus, bukan tak dengar.
Q in equal to Q out.
Yes, good. Q in equals to Q out. So basically kalau saya tanya atau anyone, you boleh cakap lah continuity equation is equals to area in times velocity in equals to area out times velocity out. Okay, thank you so much, Harith and also Razi. So next, we call it as energy equations or Bernoulli equations because it's follow Bernoulli principle. Amanina Husna. Formula for energy equation? Ada tak Amanina Husna? Ataupun Bidah. Nur Abidah binti Zulkifli. Masih dengar suara saya ke? Dengar. Putri ke? Putri Husnia, any girls lah? Tadi kita dah tanya on male side. So, can we have the girls for the energy equations ataupun Bernoulli equations? Anything that you remember or you understand on this one? Ada tak? Amanina Husna, Nur Abidah, Nurul Husnia, Nurin Najla Najiha, Putri Nur Syuhana. Mana ni? Dengarkan suara saya. Mana dia orang ni? Ke ada masih yang nak mendaftar kuliah lagi hari ni? Dah boleh attend kelas kan today? Lama sangat ni. Anyone can help? Siapa yang mendengar ni? Boleh bagi tahu what is the energy equation or Bernoulli equation? Apa tiga energi yang terlibat in the conservation of energy for fluid flow in a pipe? Tiga apa?
Potential energies.
Pressure, kinetic, and pressure.
Okay, good. So pressure, P equals to rho G, kinetic V squared over 2G, and last one is potential.
Exactly.
Okay? So kalau orang tanya energy equation, dia tak boleh buat one side saja. Dia kena ada two side.
Two sides.
In and out. Okay, dan you label lah A ke B1, P1, V1, Z1, Z2, P1, Z2 V2. Okay, so from this equation, you should know bila nak guna continuity equation, bila nak cari discharge. Sebab dia related to Q. Okay, bila nak guna energy equations, when the questions are related to pressure, elevations, potential energy ataupun velocity. Okay, kita nak tahu kelajuan fluid in a stream tube. Okay, next we will learn flow measurement today. Flow measurement ni actually related to device. So bila on site, bila you kerja on pipeline ke later, bila kita on site, kita guna device. Okay, this is the principle atau teori yang you kena tahulah. But actually during the site, kita ada device that can detect all the velocity area. So you should know specific device yang boleh kita guna. Okay, untuk certain condition of the stream tube tu. Okay, let's see the learning outcome first. So this one you need to focus for this topic. Identify the flow measurement. We have open channel and also closed channel. So open channels ni macam lakes, river, tank, closed ni pipe lah, pipeline. Okay, and then of course solve engineering problems related to both channel on the flow measurement. Okay, flow measurements required for many reasons. So first thing, we use flow measurement to monitor the fluid system. So using this one, you can ensure adequacy of water distribution network. Okay, so we have certain or some instrument that give direct reading, while others measures of parameter can be converted to flow parameter using formula. Okay, sometimes the device ni dia boleh bagi tahu velocity saja. So using the principle yang you belajar sebelum ni, we can calculate another parameter. If with only one direct reading, you can get more information from that. Okay, so this one is the factor used, how we select the instrument to use. So we have range. Range ni is the amount of fluid, sama ada bulk ke, condition dekat river ataupun tank, pipe. So amount dia berbeza, so perlukan alat yang berbeza. And then depends on the accuracy. Basically, accuracy is important thing in reading the result tu. Tapi it can consider in terms of price pula. Okay, basically kalau accurate mestilah mahal. Sama lah. Okay, bila benda yang accurate, alat yang accurate, basically lebih mahal. So kalau kita tak perlukan yang more accurate, kita boleh guna yang biasa sahaja. Okay, so and then factor of energy losses. So for this one, we need to have proper factor adjustment. So kita akan ada back calculated on the energy losses. Mungkin direct reading ni kita perlu buat adjustment lah. We need the coefficient factors for correction. Kita ni sambung ke atas ni. We need adjustment for correction. So this one yang you akan belajar on this week. Because we are doing it on site. Sebelum on site, mesti ada error. So we need the factor adjustment to get the real result. Okay, and then factor of cost. Okay, so this one basically the device that you might learn. Sebenarnya ada 4 je, tapi nampak macam banyak kan? Because it is same thing lah. So firstly, pitot tube, venturimeter, this one samalah orifice. Okay, orifice ni adalah holes. Holes pada tank. Okay, basically it involves tank. So, laluan tank ni dia boleh ada dekat side. Contohnya kita ada holes kat tepi. Ataupun we have the holes at the bottom. Okay, so orifice ni adalah hole. So, bila air keluar daripada tank, kita akan panggil dia sebagai water jet. Okay, air yang keluar daripada small hole, we can represent the flow of the water as a water jet. Sama juga macam dia keluar daripada nozzle, hose. Okay, we call it as water jet. Okay, what is the difference between large dengan small? Ni adalah dia punya shape. Small, shape of the water is circle. Shape of the hole. Large ni rectangle. Shape dia. Okay, basically bila hole tu besar, you akan nampak macam rectangle kat sini. Okay, but it's the same thing. We call it as orifice, which is hole, sama ada dekat on side ataupun bottom of the tank. So kat sini you boleh different lah. Okay, pitot tube ni untuk pipe. Orifice is for tank. Okay, and then we have notches and weirs. Ni sama. Beza dia notches ni untuk flow of the tank, tapi dekat bahagian atas. Okay, flow dekat bahagian atas of the tank. Dia bukan hose. Okay, that is notches. Okay, weirs pula dia adalah sesuatu yang lebih besar daripada notches, kita panggil weirs. So basically weirs ni adalah overflow from the river. Air terjun yang turun daripada dam ke, that is weirs. Okay, so weirs ni basically lebih besar dan dia overflow. Dia tak ada bahagian atas ni. Dia overflow daripada boundary yang belah atas ni. So notches kita ada juga boundary dekat atas sikit. Sebab dia tak overflow from the border, boundary. Weirs ni basically dia akan overflow. Okay, so before kita go deep into one by one of this instrument, saya nak tunjukkan a little bit on the summary. So saya share another slide. Still can hear my voice kan?
Yes, doktor.
Okay. So now can you see this one? Nampak tak?
Nampak.
Okay, so this is the table to simplify all the device that you might learn. So let's see on pitot tube, dia punya characteristics dia adalah L tube. So dia punya shape adalah L. Okay, then this pitot tube can measure velocity. Okay, at the site and location, nanti you nak buat practical task ke siapa yang terlibat on the water resource punya part. So you can know pitot tube is for open channel and also closed conduit. Okay, for venturimeter, it is like the converging tube, U-shape, basically U-shape lah. Yang you belajar on the pressure measurement, manometer. Okay, it is related to venturimeter, U-shape manometer. Okay, this one is to measure velocity and discharge. Okay, so venturimeter is only for the closed conduit. Yang open channel for tank tak boleh guna venturimeter. Okay, so for orifice, it called as opening ataupun hole. Okay, what orifice can measure? They measure velocity and also discharge. Okay, another part is time taken to empty the tank. So basically kalau kat jambatan air, kita ada sesuatu masa untuk empty the tank dan kita replace dengan air yang baru. So kita panggil macam clean up lah. So we use large orifice untuk measure the time taken that take to empty the tank. Okay, so basically this one orifice dia kat bahagian bawah. Okay, because we need to empty the tank from below. Okay, empty the tank ni important lah. Sebab ada case previously orang meninggal dalam tangki air. Okay, so we need to clean and check the tank regularly. Okay, so side and base ni refer to all orifice. It can be side or base, bottom. Okay, and then notch is called as large hole. No upper edge, maksudnya dia overflow from the above tank. Contoh dia macam ni. This is notches and weirs. They overflow from above the tank. Okay, we consider as the holes at the above part of the tank. Okay, so for this one ada nak tanya tak? Before we go further. Tak ada kan? Okay, tak ada tak apa. So now we back to previous slide. Nampak kan? Flow measurement ni. So still on that slide.
Nampak Doktor.
Okay, now today I think we cover on pitot tube sahajalah. Okay, so we have pitot tube. It's used to measure the velocity. It consists a simple L-shaped tube facing the oncoming flow. So the facing ni important because you cannot put the pitot tube inverted. Okay, dia mesti follow the flow of the water, the flow of the fluid. So this one salah lah. Okay, we need to be facing the upcoming flow. Okay, so we consider the velocity of a stream at A. So we have the point A. We represent as U. U ni maksud dia initial flow lah, in. So it moving from A to B. So B ni we call it as rest condition. Okay, sebab dia nak masuk kat sini perlu berebut-rebut air ni. So kat sini the velocity will be 0. Okay, dekat point of the B ni dia punya kelajuan akan rest. Okay, so it consider U is velocity. Previously we can also represent by V kan. So for now we use V, so U naught is 0. Okay, so we have pressure at point A, pressure at point B, and then you also have a V ataupun U. So the first V is, we have the V. So V note here, V is 0. Okay, so the Z is the elevations. This H is represent the velocity ataupun represent the kinetic energy ataupun pressure lah. Okay, of the total energy total, this H is total energy that include pressure energy, kinetic energy and potential energy. Okay, so senang lah, you letak je pitot tube ni on the side. You measure ketinggian H ni, kita dah boleh tahu dah berapa total pressure inside the pitot tube, inside the pipe. Okay, so So you still need to use the continuity equations and Bernoulli equations. So this is the energy equations or Bernoulli equations. So we have pressure energy, kinetic energy, potential energy. So kat sini dia tulis U. So kalau you tak nak confuse, you tukarlah jadi V. V je. Okay, formula dia still same on the Bernoulli equation. Okay, so how we can cancel velocity. Kat sini tak ada kan, tadi kosong. Okay, we have the pressure. We have the Z for both lah. Ada Z. Okay. So finally, kita akan dapat equations. Pressure energy equals to Z. This is for in. For out, yang tinggal adalah pressure energy and H plus Z. Okay, so what is the difference between flow measurement using device dengan yang awak kira before this? We need a correction tadi. So we need the C. So you nampak C kat sini. Coefficient. So we need to make a corrections for the V theory. So we can know the V actual ataupun we call it as V real. Okay, so after cancel all the zero punya condition, so finally for pitot tube, we calculate the velocity as square root 2 times gravity times the H. Okay, so we just use the H yang kita guna untuk measure energy dalam pipe. Okay, so kalau pitot tube, kita guna V theory square root 2GH. So when we calculate the V real, you need to use the coefficient here. These coefficients, sebab dia velocity, so it is coefficient velocity. Kalau dia coefficient untuk discharge, so later maybe you need to find the discharge. Kan? So discharge punya formula sama. Okay, so this is theory. So when we calculated the real situation using the pitot tube, dia akan ada coefficient. Okay, coefficient discharge basically kita guna CD. Tu je lah beza dia. Okay, the principles all the same, which is Bernoulli and also continuity. Okay. So this velocity is only for pitot tube punya calculations, which is 2GH. Okay, so let's see on the examples. Maybe dengan examples you can have more understanding on this. So ni gambaran sebenar pitot tube. Dia besi, so dia ada stagnation pressure holes. So we call it as stagnation pressure hole sebab dia punya velocity kat sini tadi zero. Okay, it also can be calculated as pressure stagnations. Okay, this is just for the information to derive that formula. Okay, ni tak adalah kita tak guna this formula in your calculation. Okay, so before that, we can also combine the pitot tube ni dengan piezometer. So siapa ingat lagi? What is function of piezometer? Kita belajar on the hydrostatic fluid pressure. So piezometer is basically to measure the fluid pressure inside the tube. Okay, so kat sini, ni nilai H tadi kan? So it can be represented as kinetic energy. Okay, so let's see on these examples. We combine the piezometer and pitot tube. into a horizontal water pipe. So bila nampak perkataan horizontal ni maksudnya tak ada elevations. If there is no elevation for this pipe, to measure static and stagnation pressure ataupun kita panggil sebagai static dynamics, we use these two. For the indicated water column height, determine the velocity at the center of the pipe. So kita nak cari velocity at the center of the pipe. Kat tengah-tengah pipe lah. So solution dia, we need to make assumption. The flow is steady and incompressible. Maksudnya dia ideal. Okay, we don't consider any losses. Okay, kita abaikan losses. So maksudnya kita kena buat assumption. The flow is steady and incompressible. Maksudnya dia ideal, tak ada losses. So that bila kita dah buat assumption, we can use the Bernoulli equation punya principle. So we take point 1 and point 2. Sebab kat sini tulis 1, 2. A, B also can. Based on the question. So we have point 1 and point 2. Okay, so basically we calculated pressure rho GH. So pressure 1 is rho G H1 plus H2. Okay, H1 ni adalah yang bawah ni . So sebelum ni kita measure pressure, kita kena kira rho GH ketinggian dia kan, from the center. Okay, so for P2 is rho GH, this H is H1 plus H2 plus H3. Okay, masuk elevation tadi Z dalam Bernoulli equation. Okay, so you can see here, when it is considered as the stagnation point and also horizontal, so the V at point 2 is 0 and Z1 dengan Z2 sama, tak ada elevation. So we can cancel the Z1 and Z2, also the V. V tadi 0, V at point 2. Okay, so finally we can solve using this one, 2GH. So we have 2, G is 9.81, dia punya H adalah H3. H yang ke atas ni, 12. 12 tukar kepada meter ialah 0.12. So the velocity at the center of the tube ataupun pipe is 1.53 meter per second. Okay. So you can see here, kenapa kita ambil 12 ni, kita tengok beza dia punya fluid. So kat sini 12. So we consider ni datum lah. So kita ambil daripada ketinggian yang point ni sampai atas. Okay. So ni dah masuk pitot tube ke? Ni dah combine pitot tube dengan venturi meter. So let's see another examples of pitot tube. Saya share. Nampak slide yang lain kan?
Nampak, doktor.
Nampak.
Okay, good. Saya besarkan. Now presentation kan? Now nampak presentation kan?
Nampak doktor. Nampak
Okay, so you nampaklah sini to be actual, kena ada coefficient tu beza dia untuk using device. Okay, so this one is another example. So let's try together. So you have a pitot tube placed at the center, which is 30 centimeter diameter pipe. So this is the diameter of the pipe. So daripada sini you can detect that you can calculate the area lah. Sebab kita dah bagi diameter pipe. Okay, so the head of water in the tube is 10 cm. Okay, maksudnya pressure yang belah atas tu adalah 10. So we have this pipe. Size of the pipe ialah 30 cm. So maksud 10 ni yang kat sini. Pressure head 10 cm. Okay, so the coefficient velocity is given 0.98. So determine the velocity of the water in the center of the pipe. Given that the mean velocity is 0.7 times the center velocity. So compute the discharge of water through the pipe. Macam nak kira? Baru tak kira discharge. Dia kata nak cari discharge. Any idea? Okay, so solution pitot tube, you just directly use velocity untuk pitot tube. So it is square root 2GH. So this C is the CV. Okay, so we have CV tadi 0.98. Masukkan 2G 9.81. H adalah 10 tadi. 10 tadi 0.1 lah kan? Cuba kira, betul tak? 2 darab 9.81 darab 0.1 square root darab 0.98. Betul tak? Betul. So dia cakap mean velocity throughout the pipe. Kita guna perkataan mean ni sebab kita nak cari macam average lah. Velocity inside the pipe tu adalah 7 kali. Kan dia kata? 0.7 kali the center velocity. So 0.7 darab 1.373. Dapat 0.96. So using the discharge punya formula, so you can get the discharge. Okay, sebab dia suruh compute the discharge. Korang kira balik, betul tak ni? The diameter tadi 30 cm, so converting into meter 0.3. So you get 0.068. Betul kan? Okay, good. Ni dah masuk manometer. Okay. So saya stop sekarang lah. Later we go to manometer. So you have another 1 hour. I need you to answer the tutorial. Sekejap saya share. Mana tutorial? Kita tengok soalan mana yang you all boleh cuba. For your understanding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 1 Keluar terus soalan 20 ni. Boleh try dah soalan 20. Soalan 20 boleh cuba. Ada jawapan tak soalan ni? Oh, ada. Oh, tak ada jawapan. Later we discuss on this one.
Doktor,
Ya?
boleh tengok tak yang tadi? Yang kita example tadi.
Yang slide tadi
Ah,
Sekejap. Ni. Betul ke?
betul-betul.
Ada soalan ke?
Betul-betul. Tengok itu je.
Okey.
Thank you, doktor.
Doktor,
Ya?
tengok dia punya soalan.
Soalan dia okey. Sekejap hang pula laptop saya. Okey ni.
Okey.
Okey?
Okey dah doktor.
Okay, so let's see on the salah pula. On the tutorial tadi, cari yang berkaitan dengan pitot tube. So this one yang lain ni boleh je cuba. If you have macam more time lah. Basically, manometer kita guna untuk pipe yang berlainan saiz. Macam ni kan? Besar kecil kita guna venturimeter. Basically untuk pitot tube biasanya size of the pipe sama. This one pun banyak yang venturimeter. So we can say that soalan pitot tube ni jarang-jarang jugalah. Yang famous adalah orifice dengan venturimeter. This one, different size of pipe, kita guna venturimeter. So setakat ni soalan 20. Ni pun orifice. Rectangular holes located at the bottom of the tank. Memang kurang soalan pitot tube ni. Mostly memang banyak orifice dengan manometer. But you still need to know. Bila you kerja nanti, maybe you can apply on that lah. Pun eventually. Tak ada, satu soalan je. Bolehlah cuba this one. Atau you can refer soalan past year. Nanti saya tolong carikan jugalah sebab pitot tube ni jarang keluar soalan. Okay. So, satu soalan je. You have 1 hour. Banyak masa tu. Boleh try. Thank you. Ada soalan lagi tak sebelum we end the class?
Tak ada dah, doktor.
Okay, tak ada. If anything, you can WhatsApp saya lah.
Alright.
Okay. Thank you very much. Bye-bye.
Thank you, doktor. Assalamualaikum.
Welcome. Waalaikumsalam.
Happy New Year, doktor.
Ya?
Thank you, doktor.
Happy
bye.
New Year.
Happy New Year.
Thank you, doktor.
Bye.
Doktor.